Welcome students. Today I am going to explain part 2, our third lesson, elements, compounds and mixture. Students, before that part, first I explained to you about the elements and compounds. Now, what is meant by mixture? Mixture is also the kind of matter which is made up of two or more pure substances. Many examples are there around us of this mixture. For example, milk, tap water, honey, milk and ice cream. Many examples are there of this mixture. Students, mixture are made up of the substances that we called as a components or the constituents. Now, the characteristics of the mixture. The first characteristic of the mixture is that the mixture are made up of two or more pure substances by any proportion, and they not change their chemical composition, only they are making by any proportion. That's why the mixture are called as a impure substances. Second characteristic of mixture is mixture may be homogeneous or heterogeneous. Third characteristic of mixture not having fixed boiling point and melting point. Whatever the components we are adding in the mixture, it depends on the quantity of the components that making the mixture. Now the next characteristic of the mixture is that mixture are not writing with any chemical formula. Next characteristic of mixture is that mixture is separated by any physical method. That is simple method. And next characteristic of the mixture is that there is no evolution or absorption of the energy. So students, these are the characteristics of mixture. Now our next topic, which are the types of the mixture? Depending upon the composition, there are two types of mixtures are there. The first one is the homogeneous mixture and second is the heterogeneous mixture. Homogeneous mixture means, students, the component of this mixture is uniformly distributed with each other throughout its volume, and we are not able to see any components. So that we called as a homogeneous mixture. Salt and water. Heterogeneous mixture is forming with the help of the components which are not dissolved uniformly with each other, and we are able to see this component, that is called as a heterogeneous mixture. For example, water and sand. Water we are able to see and sand is also able to see of the mixture of water and sand. Now students, we are going to explain the next topic about the types of mixture depending upon their state. Depending upon their state, that mixture we have to explain now. So the first one I want to explain the solid plus solid. Both components are solid. They are forming homogeneous mixture and heterogeneous mixture. Now students, see this table. That table is giving the example of the homogeneous and heterogeneous. Second example is that solid plus liquid. And third example is liquid plus liquid. And the next example is the liquid plus gas. And the last example is gas plus gas. So students, these are the table for the homogeneous and heterogeneous mixture. They are the solid and solid liquid. So depending upon the state, that table is there. Now students, separation of the components of the mixture. Why we have to separate the components of the mixture? So students, the reason is that when the mixture is containing the components, sometimes these components are harmful to us, and if we want to use our daily purposes, so we have to separate them components, and we are getting the pure substances. So the pure substances are useful to us, and these harmful substances we are removing from the separation. This is the reason for that. For example, students, seawater is the example of the mixture. So students, that salt containing in the seawater, but we are not able to use directly the seawater as the salt. Salt is containing nutrient also, and salt is giving the taste to the food also. But when we are separating the salt from the seawater, then that salt we are using in our daily life. So that is the need of the separation of the mixture. Now students, we are going to explain the different method of the separation. And the first method I want to explain based on the solid-solid components. Means both components are the solid-solid, we have to separate. And the students' first method is the mechanical separation. This is also called as a hand picking method. Now students, hand picking method, when we are using this method, the components are present in the mixture, that is in the small quantity, and what component we have to remove by the hand picking method, that should be larger in size. And after that we are able to see, so the color is different and the size is different, then we are able to use the hand picking method to separate the components of the mixture. Students, for example, pulses and stone, then rice and chop and stone. So we are separating by using the hand of this chop also and stones also. Second method students is the magnetic separation. Students, we have to see in the mixture, the one component is having the property of the attracted by magnet. So that time we are separating by the magnetic separation. For example, iron and sand, iron and salt. So if we will use the magnetic bar, bring the magnetic bar near to the mixture of salt and iron. So iron particles are get attracted towards the magnet, and the remaining one is the salt. So in that way we are able to separate by the magnetic separation. Students, again the examples are there. Nickel, cobalt, these are also the magnetic substances which are attracted by the magnet. And if any one component is the nickel or the cobalt, we are able to separate by magnetic separation. Now students, third method is the gravitational method. In gravitational method, the both components are the solid, but one component is heavier than the solvent and one component is lighter than the solvent. By gravitational method, one component is heavier than the solvent and one component is lighter than the solvent. So the density is high, automatically it will come downside, settle at the bottom of the solvent. And which density is lower, it will float on the solvent. So after that we have to decant this solution and then we have to separate with the filter paper. The residue will collect, and that method we called as a gravitational method. For example students, if we will take in a half glass of water and we have to add the mixture of the sawdust and the sand. So sand is heavier than the water, it will settle downside. And the sawdust is the lighter than water, it will float on water. So decant the solution in another vessel with the help of filter paper and a funnel. Then the filter paper collecting the sawdust and the sand will remain in the first vessel. That separation is called as a gravitational method. Next method about the separation of solid is students, sublimation. And we learn what is mean by sublimation. Sublimation is the process. Solid state is changed into the vapor state by heating and again come back to the solid state. So this process is called as a sublimation. Students, in laboratory, chemical we are using, that is ammonium chloride and common salt, are get separated by the sublimation process. If we will heat the mixture of ammonium chloride and common salt, by the sublimation process, ammonium chloride is, we have to use the inverted funnel, and that inverted funnel collected the vapor state of the ammonium chloride, and after cooling we are collecting that. So students, in sublimation process, ammonium chloride and common salt is separated by this method. And ammonium chloride, when we are giving the heat, it's transferred into the vapor state, and after cooling again it transfer into the solid state, so that we are to collect another, and remaining is the common salt. So the separation is going on with the help of the sublimation process. But here one condition is there student, the one component is having the property of the sublimable. So that substance should be the sublimable substance, then only the sublimation process is possible. So for example, naphthalene ball, second one is the camphor, ammonium chloride, iodine. These substances are showing the sublimation property. And when we are using the one component is this process, the one component is present, that time we will use the sublimation process. Now students, the next one is the solvent extraction method. Student component is insoluble in solvent, and after that we have to use again the decantation, and then after that we have to separate the two components. For example, salt, water and chalk powder. So the separation of chalk powder and the separation of chalk powder and salt, if we want to separate, so this mixture we have to add in water. So salt powder is dissolving into the water and chalk powder is not dissolving in the water. So we have to pour this solution into the another vessel. That process we called as a decantation, and use the filter paper. So filter paper will collect the chalk powder, and the remaining is only the salt solution. That salt solution we have to give the heat. So whole water will evaporate, remaining is the salt powder. So the chalk and salt, that separation is doing by this method, that is called as a solvent extraction method. Students, all components are not soluble into water. So some substances are soluble in their solvent. In that way we have to learn that we have to see the solubility, then we have to decide. The students, for example, potassium nitrate and water, both are soluble in water, but the solubility of potassium nitrate is more than the sodium chloride. Fractional crystallization method we are using. We have to heat the mixture of potassium nitrate and common salt, that is sodium chloride. After getting the heating in the water, so cool it, and after that we are getting the crystal of potassium nitrate, because the potassium nitrate is soluble, highly soluble in water than the common salt. Again we have to repeat the process. Again we have to give the heat, boil the mixture. Again cool it, you will get the potassium nitrate crystal. Students, this method we have to repeat it up to that potassium nitrate and common salt, that is separated from each other. Now students, separation of solid liquid mixtures, and the first method is sedimentation and decantation. The settling down of suspended insoluble heavy solid particles in a solid liquid mixture when left undisturbed, this is called as a sedimentation. And the solids which settles at the bottom is the sediment, and the clear liquid above, it is called supernatant liquid. And the process of pouring out the clear liquid without disturbing the sediment is the decantation. And students, this method is used for a heterogeneous mixture of solid and liquid. Example, a mixture of sand and water. Insoluble solid particles from a liquid solid mixture by allowing it to pass through a filter is called filtration. And the insoluble solid left on filter is the residue, and the liquid which passes through a filter is the filtrate. And this method is used for separating the components of solid liquid mixture in which solids are insoluble in the liquid. An example is chalk and water. Third method is the evaporation. Evaporation is the process of converting a liquid into its vapor state, either by exposing it to air or by heating. This method is used to separate the components of a homogeneous solid liquid mixture in which only the solid is recovered while the liquid escapes from the vapor. For example, salt and seawater is separated by the evaporation. Fifth method is the distillation. Distillation is the process of converting a solid into vapor by heating and the subsequent condensation of the vapor back into the liquid. This method is used to separate the components of a solid liquid mixture in which both liquid and solid are recovered. And when the solution is heated, the liquid evaporates in the form of vapors which pass through the condenser and get condensed into pure liquid, which is called as a distillator. Tap water, a mixture containing dissolved salt, is purified by distillation method. Sixth method is the centrifugation. Centrifugation is the method of separating solids from liquid where the mixture is homogeneous. An apparatus is called as a centrifuge. The mixture is placed in the centrifuge tube and rotated at high speed, due to which the heavier solid particles move towards the bottom and the light solid particles float on the liquid. This results in the separation of substances of different densities. An example, cream is separated from milk by this method. Next is separation of liquid-liquid mixture, and the first method is by separating funnel. It is a simple device used to separate the components of a liquid-liquid immiscible mixture in which liquids have different densities. The mixture of kerosene oil and water is placed in a separating funnel and allowed to stand. The components form two layers, water being heavier, it is the lower layer, and kerosene oil is lighter, it is from the upper layer. And when the stopper of funnel is open, the heavier liquid trickles out slowly and collected in vessel. Then stopper we have to close when the lower layer is entirely removed from the funnel. In this way, the two liquids, kerosene and water, is separated. The next method is the fractional distillation. This process of distillation is used for separating the liquid-liquid homogeneous mixture in which the liquids have different boiling points. On heating the mixture in a distillating flask, the liquid with the lower boiling point converts into vapor first and then gets condensed and collected in a receiver. The temperature remains stationary till the whole that liquids distill over. The heating is now continued. The temperature rises and the second liquid starts vaporizing at its boiling point, and then these vapors condense and collected in another receiver. Complete separation is possible only when the differences in boiling points of liquid is 30 degrees Celsius or more. If the differences is less than 30 degrees Celsius, fractionating column is fitted over the distillating flask, and this method is called as a fractional distillation. And the example is the water and alcohol. The third method is the chromatography. This is one of the latest technique to separate the components of a mixture when all the components are very similar in their properties. Example, component of ink is separated by this method. Ink is a mixture of different dyes which is separated by chromatography because some of the dyes are less soluble and some are more soluble in a solvent. And common adsorbent used are filter paper, silica gel, and common solvent used for chromatography are water, ethyl alcohol and acetic acid. Principle involved in chromatography is that the chromatography separates the components of a mixture on the basis of differences between two phases. One is stationary and the other is mobile. And the simplest type of chromatography is paper chromatography. In this method, a special type of paper, that is the chromatographic paper or the Whatman filter paper, is taken. A line is drawn with the pencil near the bottom edge of paper. A drop of mixture then we have to place on the filter paper above this line, and the paper then dipped in a solvent taken in a beaker such that the line drawn on the paper is above the level of the solvent. The filter paper acts as stationary phase while the solvent acts as mobile phase. As the solvent rises on the paper, it takes along with its constituent substance of the mixture. The component of the mixture which is more soluble rises faster, and we will see the spots on filter paper, each indicating a component of mixture. The paper is then removed and dried. The advantages of chromatography are a very small quantity of substance can be separated. Components with very similar physical and chemical properties can be separated. Then it identifies the different constituent of mixture. It also helps in quantitative estimation of common components of a mixture. Then application of chromatography is that to separate colors in dyes, drugs from blood, pigments from natural colors, and to purify many industrial products. Now the next method is separation of liquid gas mixture. A liquid gas mixture is separated by boiling it. So dissolved gas escape from the liquid on heating or boiling. Drinking water contains air dissolved in it. So boiling from that air escape from it and the boiled water become tasteless. And the next and last method from this separation of gas mixture. And the first is the diffusion. This method depends upon the differences in the densities of the gases present in the mixture. The lighter gas diffuses more rapidly compared to the heavier one. Example, a mixture of hydrogen and oxygen can be separated by diffusion as hydrogen is lighter than oxygen and diffuses first. Second method is solvent extraction. This method depends upon the fact that some gases dissolve in water or in some other solvent, while some gases do not or less soluble. For example, a mixture of carbon dioxide and carbon monoxide separated by this method. Third one is liquefaction. This method depends upon the fact that some gases like ammonia, carbon dioxide liquefy easily at high pressure and low temperature, while the others are not easily liquefied. Example, a mixture of ammonia and nitrogen in which they are separated with the help of liquefaction process. Students, here we completed our part 2 from lesson number 3. Thank you.